All right, let's look at one more video on, or make one more, on horizontal projectiles. Okay, so last time we had a bunch of things and we looked for things. Let's go ahead and look at final velocity this time. So if you want, we could go back to the previous problem that we had here where this ball rolled off at that speed and say figured out, well, how fast was it going when it hit the ground? So if I were to continue with that, I'd start with the same things I had here. I'm going to pretend I don't know time, just in case I messed up here and I got these parts wrong, but I still could possibly get some points by getting this right. And now I'm looking for VF equals question mark. Okay, this is the VF, of course, in the Y direction. I don't need to write it because it's in the Y, but I'll just do it anyway. And so if I wanted to solve that, you see that without this being there, so I'm just going to put a pencil on that, what equation has all four of these variables, and I think you'll see it's number 4. And so I would say VF squared is equal to VI squared plus 2A delta Y. And so VF squared is going to equal to 0 squared plus 2 times negative 9.8 times negative 1.2 meters, because my delta Y up here is negative 2 meters. Okay? So now you've got this, and it's pretty simple to go ahead and multiply these out. And that would be 2 times negative 9.8 times negative 1.2. And that gives me 23.52. That's my VF squared. That's 23.52. So clear VF is going to be before VF equals the square root of this. Put the square root on both sides because I want to get rid of VF squared. I'm not looking for VF squared, right? I'm looking for VF. And that gives me 4.85 meters per second. Now that is not my final speed. That's my speed in the Y direction. I also have my speed in the X direction. I'll call this VFY if you want. I'll just call it VY. And Vx, we know, is 3 meters per second. This particular thing looks like a vector that has 3 meters per second this way and 4.85 this way. I'll make it a little longer to drive it to scale. So when you put these two vectors like this, head to head, you pick this vector up, and you're adding two vectors, draw the first vector and you draw the second vector with its tail on the next vector. There's another one, you put the tail of that to the head of that, and then we go from the tail of the first to the head of the last. So the tail of the first to the head of the last, and that kind of gives you the arrow of your final velocity. Of course, so this is also 3, so you can use the Pythagorean here and say that V, which is really the actual V up here, the velocity of, or the speed, the velocity is made up of two parts. The velocity is actually pointing that way. And so that's just going to be 3 squared plus 4.85 squared. It is 4.85 right there. And so that would give me, and that's going to be my V squared, right? And so we're looking for V, which we're going to do by finding the square root of that later. So this would be 9 plus 4.85 squared. That's 32.52. I take the square root of that, and I get 5.7. So V is going to be 5.70 or 5.7 meters per second. So that's what you would call the speed, because that's the made up of both the vectors together. That's the real velocity. Remember, the speed is the length of the vector, while the arrow is the direction of the vector. And so my velocity is 5 meters per second. For on-ramp kids, you could write your V as equal to 3x hat meters, 3x hat minus 4.85 y hat meters per second. Okay, so that would be in your vector form, but for the rest of you guys, that's how you can find the speed. So again, to recall, we found the final y velocity and then the x velocity. We did the Pythagorean thing on it. Okay, so basically v is going to equal to the square root of 3 squared plus 4.85 squared. Okay, I do this Pythagorean on it, and boom, I find the length of this vector, which is really the speed. Okay, so you found out how to keep that Vx is pretty much the same all the time, and Vy is the one that's changing. All right, I think I might do one more on horizontal projectiles to kind of bring out some important intuition.